Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success, commit with Geeks for Geeks.
Hi, and welcome to Geeks for Geeks. I'm Siddhartha Hazra, and today we would be discussing the Geeks for Geeks Weekly Coding Contest 155. And this is the post contest analysis. So let us first talk about the feedback of this problem. So, if you ask me, this contest was good enough if you are very good with your implementation skills, because comparatively this problem doesn't really teach us any new concepts. If you see, like if you go from the very top one to the bottom one, even the last problem is using the sliding window, but the implementation of it, because of the number of conditions it has, is quite long. So a problem which requires a simple sliding window, and like, we can get the idea. So I think that this was a kind of implementation speed contest. People who are very good with implementation, people who are like very good with their debugging skills, would be able to surpass this comparatively. Okay, so let's talk about the very first problem. If I see the very first problem in the first hand itself, it gives me an idea. Yes, they would meet at some point, and the meeting point would be a common point first. Then let's talk about the second one. So, second one, if I just think about it, and if I just have the idea of graphs, like how we use the adjacency list in graphs, then if you have done representation of graphs using adjacency list, then this problem is comparatively easier to comprehend, that yes, this can be done in this fashion. Fair enough. Let's move on to the third problem. The third problem is that you don't really start thinking about how we can compute or find different number of alternative subarrays. You should be focusing on how to maximize it. Okay, then it would be easy for you. Okay, and talking about the last problem, it was a constraint game problem. Like, it can be understood that yes, like if you see up the constraints, it seems that yes, it is doable. But the small conditions of it, like the alternating thing that happened, like once the odd index from 1 to k, the odd indices would be negative. For k to k to 2, and the odd k to 2k, the odd indices would be positive or negative. This all made the difference in the last problem. So let us head back to the very first question. Hi Nakaj, I still remember you. Okay, fair enough. So I don't. So let us start with this. So Nakaj, can you please confirm if my audio and everything is fine enough from my end or not? Okay. So let us see up this problem. Okay. By the way, once I got a LinkedIn comment message that why don't you take the screenshots beforehand, instead of doing it in the live class. It's not that I don't want to do preparation before the class. It's just that I don't really know how many pages I would require to just scribble around. So that is why I don't keep these things handy beforehand. Okay. So now see this with care, and then you would understand it. See, the point of concern was they were invited to a birthday party. By the way, the problem statement, the generation of problem statement is absolutely a treat over here. Okay. So Bob noticed Alice, who caught his eye. Okay, so there is a person named as Bob, and this is Alice. So Bob would see Alice after m seconds, and Alice would see Bob after n seconds. It might be interchangeable too. Okay, now I just want to know that at what point they both would meet each other, like their eyes would meet each other. So, for example, let's say Alice is looking at Bob after every 1 second, and Bob is looking. So, let's say this is Alice. So, let me just explain. This is, let's say, Alice, and this is, let's say, Bob. Alice and Bob. Okay, by the way, even if you interchange the values of n and m, that won't be a problem in here. So, see, let's say Alice is looking after every 1 second. Okay, and Bob is looking after every 3 seconds. So if you observe that after 1 second he saw Bob, but Bob was not seeing him back. Then after 2 seconds he saw Bob, but Bob didn't see him back. But when it is the time for 3 seconds, he would see Bob, and because this is the point at which Bob would also see, their eyes would meet. I don't really need an example because this example is good enough and hilarious even. Like I don't like I want this type of problem statements. These all problem statements help us to understand the problem better because like we take an arbitrary value of n and m, tell me the point at which they would coincide with each other. Instead of that, if we have a problem statement like this, you would get like what the problem statement is trying to tell you. Okay, so yep, so after the 3rd second they both would see. Now same goes for this. See, this is the first instance, this is the fourth. In the next instance it would go to 6, and this person, see, this is 3 and this is 4. So in the first instance 3 and 4, then 6 and 8, then 9 and 12, then 12 and 5. Sorry, did I do something? Okay, it should be 16 here. Yep, 16. So now if you observe, this is the point because Alice would also have a look at the 12th second, and Bob would also have a look at 12th second. If you just have, if you just draw out this thing for the second, just a sec. I'm extremely sorry. Okay, so if you just observe this, you just need to find a common multiple. At the common multiple of both of them, their eyes would coincide. So I know that their eyes would coincide when we have a common multiple. When we have a common multiple. Now, it is asked in the question, like, is everything fine enough from my end? Let me just see. Okay, fair enough. Everything is fine enough. So now see, I understood that I need common multiple. At each common multiple, both of them eyes would coincide with each other. Now it is also asked, if this is the point, for the first time, this is the thing that makes the difference. So I want the first common multiple. So first common multiple of two numbers, if I just add first to it, That just means that I want lowest common multiple. Okay, I just want the lowest common multiple and I would get the result of this. Okay, simple enough. Now there are many ways to calculate the lowest, that is LCM. You can simply give it a search like n multiplied by m divided by GCD of m comma n. This is the first step. Next, what you can do is, if you are a beginner and you don't know Euclidean algorithm or GCD, that is fine enough. What you can simply do is, you can simply go over all the multiples of the bigger number and see if it can be divided by the smaller number. That is, like, I can go and see if 4 is divided by 3 or not. I can go and see if 8 can be divided by 3 or not. I went to 12, I would see if 12 can be divided by 3 or not. The first point where it can be divided is our answer. This is a comparatively brute force solution if you don't know Euclidean algorithm or if you don't know the GCD thing. Okay, so this is the solution. What I can do is, I can find out the greater number and I can find out the smaller number. Then I start adding the greater number at each point. This is just like 4, 8, 12, 16, like this. And the very first point where it can divide, where it is getting divided by the smallest, is our answer, and we stop at that instance and we return that answer. Let me give you this solution. By the way, I just wanted to tell you that even beginners can solve up this problem. Like, they don't need to have a realization that I didn't knew Euclidean algorithm. I didn't knew Euclidean algorithm, or I didn't knew GCD thing. That is why I was not able to solve it. Even brute force solution would work here. This is what I wanted to depict by using up this simple solution of, like, the naive solution here. Okay, fair enough. I hope I'm clear at this point. There are very few number of people, but still, can I have a quick 0 or 1 in the chat itself? Then am I clear to you or not? Or do you need more explanation of this? And one another way is that you simply use LCM of two numbers. So just go to this and this. See, so to find the LCM, what you can do is a multiplied by d divided by GCD of a comma b. You can find out this also. If you know Euclidean algorithm, that is to find the GCD. Euclidean algorithm is used to find out GCD here. To be honest, don't really need to, like, you to understand how this is working, you can do that, but else everything is fine enough. Clear? Fair enough. Let's move on to the next problem. Damn. Chalo. Let's move on to the next problem. Is my screen still shared? Yep. See, it is told that given an array of integers, what you really need to do is, for each string in the array, calculate the sum of matching characters between that string and every subsequent string. Okay, number of matching characters. What do I mean by this? So I meant that, let's say this is A, B, C, and this is the position 1, 2, and 3. This is A, D, E, and this is B, B, C. So let's say I talk about the very first value, that is ABC. So if you observe here also, I have A in the first position and A in the first position, and rest no one. Here also, if I compare this, see here B is at its position and C is also at its position here. So I have total 3 position where it is matching with the corresponding. So for the very first string, the value would be 3 because I have 3 values. Okay, I'm releasing this. Then we talk about the very next one. Then do we have anything? Like if you observe, this is not same, this is not same, this is not same. So we don't have anything. For the third one, we don't have any string left for him, so the value would be 0. We don't have anything to compare at this point. So if you observe, that is why the answer to this is 3 itself. Okay. So now I can't really, for each string, I can't really iterate all other string. That is a brute force solution and would give you a time limit exceeded. What I need to do? So what I can do is just think of it in this fashion. If I am standing with A in the first position, if I am standing A in position 1, and if there is a person who can tell me that how many ones are there at position 1, how many ones are there in position 1, how many A's are there in position 1. Similarly, I can ask how many B's are there. Like if A is asked, I would ask A. If B is asked, I would ask the same thing for B in position 1, C in position 1, D in position 1, E in position 1. So I can say that in position 1, I can keep A, B, C, D at max till Z because I know at each position I would at max have only 26 alphabets. So what I can do is I can make up something like this. This is the idea of adjacency matrix. So what I can do is I can make up a 2D matrix like this. Okay, let me explain you that. So let's say okay. Now see. This is position 1, this is position 2, this is position 3, this is position 4, 5, 6. Let's say only 6 because I have my head over here. I know that. So now at position 1, here I would have the count for A, B, C, D, E, F, and this would go on till Z. That is 6. That is 26. So I can keep the count number of A's in the first position. Let's say that value is 2. Number of B's in the first position, the value is 3. I can keep something like this. Now let us see for this. How would we process all the strings? How would we process it? That I don't really am getting you. So what we can do is we can simply have this is to visualize that what would be the size of that. Okay. So now see, we have something like, we know that there are size 3 only, so let's have just 1, 2, 3, and here we have A, B, C, D, E. So let's say this is A, B, C, D, and E. And I know at max I can have only till Z. So now see what I can do. I go to the very first value, A in the first position. So A 1. So I would increment 1. Rest all values are, let's say, 0. Then B in the second position, 2B, 1. C in the third position, 3C, 1. Then we have AA in the first position. So this automatically becomes true. D in the third position. Okay. D in the second position. So 2D, the value would be 1. E in the third position. So 3E, the value would be 1. B in the first position. So B, 1. B in the second position. So this would be 2. C in the third position. So for C, the value would be 2. Now, what are the different other values we have? The other values we have is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. And let us have this. This value would be 2. And this value would be 2. Let's just have this as neatly. Okay. So these are the values. So now if I go to the first string, A, B, C, first I would remove all the contribution of myself. So I would make this, go and make this as 1, go and make this as 1, and go and make this as 1. Now what I would do, first I would remove the contribution of myself because I want the contribution from others. So I would simply go A1. What is the value? 1. Then B1. What is the value here? 1. C 3C. What is the value? 1. So the value for the first string would be 3. The value for the second string, first we would remove the contribution. Okay. 2A, the value would be 0. Then 2D, the value would be 0. And 2E, okay, the value would be 0. So this is how we would have the value 0, 0. This is the idea itself. Okay, basically we would have the idea of adjacency list. So this side would be what? The maximum length of the array. So this side would be max length multiplied by 26, and we can process it. This would be the size of the matrix itself. And we can simply hash it, and then we can either go from back or start from the front, remove the contribution, and then move forward, whatever is your personal preference. So what we can do is max length. So you can find out the max length, or what you can do is you can simply see that the max length would be 200 to the power 5. Okay, so I would simply make max length as 200 to the power 5, just add 5 plus, because I don't know really, like, this is my personal preference, like I just add 5 plus, so that even if my algorithm is 0 indexed or 1 indexed, I don't really need to care about it. Now for each of the index, we have a 2D array of size 26 for each of the index. This is just like having a array of size 26 at each index with the initial value as 0. Array of size array of size 26 for each index with initial value of 0. This is what I want. Now I would simply start iterating from the back. That is also feasible. Like, you don't, so first I add it, then I add the contribution of it, and then because I started from the back, I would simply reverse it. Or else, if you want to do it in the ordered manner, what you can do is you can first decrement its them, like I would first decrement my contribution, and then I would find the value for the corresponding contributions, and then I would simply return. Then in that case, you don't really need to reverse it. So now let me return this to you. Anyone has any concern or queries, or this is good enough? Just give me a quick 1 or 0. Which is the contributor. Second is contribution. Take what is meant by removing contribution of myself. See, for each of the string, for each of the string, I want to know. I want to know who all are there like me. Okay. So let's say I would give you the intuition of this. Let's say this is Siddhartha Hazra who likes competitive programming. This is Ankit who likes web development. This is Manish who likes Android development. This is, let's say, Varun who likes machine learning. So what I did was, and there is few more people like, let's say, Nitin who likes CP. Okay, so I just want to know how many of people likes CP like me. So I would say CP is equals to the value 2. First, I would have the value of everyone. Web dev is equals to 1, Android is equals to 1, machine learning is equals to 1, and and CP is equals to done. Now, if I want to find out how many people are there who are alike me, so this is giving me the value of 2, but there is only one people. And the value 2 is there. Why? Because I am counting myself in this frequency array. So here what I am doing is, what I can do is I can first remove my contribution and then I can take the remaining contribution of it. Then it would give me the correct thing, like how many people are alike me, not including me. In the same manner, here also in this question you are asked that sum of matching string. So calculate the sum of matching string. Calculate the sum of matching between that string to every other subsequent string. So it means that me to everyone else. But here me to me, I would also add na. That is why to prohibit myself from adding me to me, I first subtract the contribution of myself and then I see what is the remaining contribution. Or else what you can do is, one simple idea would be that you just subtract -1 from each of the frequency that you are getting. Like here what you did. Both are equal. Am I clear? Arthav Palarvar, am I clear to you? Just give me a quick. Okay. What is the name of the algorithm? See, if you just if you are good, like this is the idea of contribution technique, but you don't really need to understand contribution technique, to be honest. If you have solved like representation of graph using adjacency list, then this problem is a cakewalk for you. Yup, I would say so. Actually, the thing is, I would tell you the idea that in like nowadays what people do is, people consider, like what happens is, people consider graphs as a complex part. So what they do is, they first complete all the static data structure, then they move to trees or graph. Okay, people do this, but what needs to be done is, if you just observe the USACO guide, which is USACO guide itself, what they do is, if you go to the bronze silver section, they do what? See, here they are only learning graph traversal, flood fill, and simple tree algorithms. Okay, like the basics of the graph they are doing in the beginner stage only. Then as they move forward, like if you go to gold, then you would see shortest path. So this is a problem in like the style of people knowing, like studying programming. So it's just that the correct pathway would be that I complete the basics of all data structure, then I move to the intermediate of all data structure, then I move to complex of all data structure. This is the correct manner, like a BFS approach. But what in India people do is they first complete arrays, then they complete stack, then they complete queue, then they go to priority queue, then they go to tree, and then they go to graph. But the basics of graph requires the basic understanding of you. So the basics of graphs and trees can be done even when you are a beginner. So this is the difference in understanding on this. So I just wanted to show you that this is not my personal preference, which I'm saying you, and you would realize that I didn't follow the roadmap of Siddharth, and that got me into trouble. That is not the issue. This is the prescribed like roadmap for you. Okay, so I I know many people and even my friends who say that first I would complete array, then I would complete linked list, then I would complete queue. That is not the issue. You should like the idea is to get problem solving. It's not that your interviewer would tell you, okay, let's first ask you question from array. If you are able to do it, then I would move on to graph. If you are able to answer questions over graph, then I would move on to TP. That doesn't goes that way. In an interview, you can be given the questions of any data structures. There is a concept known as difference array. Okay, and that is an optimization over prefix sum. And that is considered to be complex, but it comes under arrays only. These all. Okay, we can solve it using bits. Yes, bit manipulation is also the same way. Like in each number, you store the value, but that would be complex for a beginner. I would say so. Let's move forward to the third problem. Okay, this is a problem which I liked it comparatively. I didn't like it that much, to be honest. Okay, so see, here you need to focus on the goal. This is the solution, I would say. Here you just need to focus on the goal the question is asking up. What is your take over this? This is what is. So, so are you how you all are doing? Are you learning something out of this? What are your feedbacks over this weekly coding? What do you think the modification should be done in weekly coding? Okay, now see the idea is very simple. You need to find the maximum number of alternating substring that you can create by inserting at most 0 and 1 at any place in the binary string. At most 1 0 or 1. At most 1 0 or 1. Okay. So I need to find at most 1 0 or 1 and maximize. What is the idea? Maximize the count of alternating subarray. Maximize the count of alternating subarrays by doing what? By adding 1 0 or 1. This is what you can do. Let me first explain you the idea. So alternating subarrays. Okay. So this is given a binary string. So let us understand a very simple concept. So let's say we have 0 1 0 1 0 1. Let's say we have an alternating substring string, and then we have 1 1 1 1 1, and then we again have 1 0 1 0 1 0 1 0 1 0. We have this. Let's say. Okay. Now see how many substrings, how many alternating substrings would be given by this substring. So if you take out all the possible substring from this alternating substring, all the substrings, see that would be 0, 0, 1, 1, 0. This is all the substrings of size 2. So, okay, this is 0, 1, 0, 1. So, see, if I just show you, it would be very difficult to write. See, if you take out any substring of this alternating substring, let's say of size 3, this is alternating, this is alternating, this whole string is also alternating, this whole string, this is also alternating, this is also alternating. So what I claim is every substring of this is alternating. Okay, every substring of an alternating substring in a binary string is alternating. How? You can see it for yourself. This is an alternating substring, and if you take any substring out of that, any substring arbitrarily, I'm just not taking that. You can select anything out of this, anything. I wanted to show you all the substring, but that would be absolutely very big enough. Okay, any substring, take it arbitrary, that would be alternating. So what I say is every substring in alternating binary string is also alternating. So the total number of alternating substring from this string would be how much? See, as every substring is alternating, as every substring of this current string is alternating, what I can say is that length multi. So I would simply search number of substrings, number of substring in a string. I would simply search because I know. So total number of substring in a string is n multiplied by n plus 1 divided by 2. So I would say, so I can say what is the length of this? The length of this is 1, 2, 3, 4, 5, 6. It is 6. So I can say length multiplied by length plus 1 divided by 2. So I can say simply that 6 multiplied by 7 divided by 2 is equals to 3. So there would be 21 substring that would be alternating, that would be contributed from this substring. I can say that. I can say that, na? And here also would be the same. Like here also I would draw the same conclusions, and I can say 6. Here also I have 6 characters. So total number of substring that this would also contribute is 21. Total I have 42 substrings from these two substrings. I can say that. Okay, fair enough. I would use up this approach and I would count. I would use up this approach and I would count all substring count of alternating. All substring count of alternating. I would do this. Now, how I would do this? Let me just write it all. Let me just show you also. See, what I did was I started off from I, and then I kept going until it is alternating, that S of j is not equal to S of I minus 1. Then I'm just inserting the difference in the string. Now, what would be the length that would get contributed from this? That would be n from each value, that would be n multiplied by n plus 1 divided by 2. This is the total number of substring that would be alternating from this binary string. Fair enough? We can do this. No need. So what people did was, I would also tell you what people did. Okay. Number of alternating substring. So what people did was people came here and used up this DP approach. But that is comparatively and overkill, to be honest. Okay, that is comparatively an overkill. So I don't think DP is required over here. You can simply move forward with simple approaches. So this is the idea that we can count the total number of alternating. 101, it would be 1001, 101. So one is getting repeated. Total number, it is not asked that the total number of unique substring that is alternating. It is not asked that. So one and one, they both would be contributing one and one to the answer. Okay, it is not asked total number of unique values. So I should be clear till this point. I should be clear. So I, for the time being, I'm just removing this. Okay. Now, now the next one is count of all substring that is alter. After we have found out that yes, this is contributing, let's say 10, this is, let's say, contributing 12, this is, let's say, the contributing 5. Okay, so let's say we would take smaller values to make it more feasible. So let's say we found out that this is contributing 2, this is contributing 3, this is contributing 4, this is contributing, let's say, 1. Okay, count of also, let's say we have this, we would have this. Now if I have a 0 or 1 here, then this whole part would become, let's say this is A and this is B, let's say A is equals to 2, B is equals to 3, then this whole part would become a substring which is alternating by keeping here 0 or 1 optimally. If I keep here optimally, this would become an alternating one. And they now, instead of contributing individually both of them, they would collectively contribute to the answer. Now earlier the answer computed of a multiplied by a plus 1 divided by 2 added to b multiplied by b plus 1 divided by 2. Earlier this was the contribution. But if I make this new contribution, this would be a plus b, because this would collaborate with each other. And we have added one more extra. So now the new length which is popping up is a plus b plus 1. So what I would do is, I would first, it's the same idea, I would first remove the contribution of these two and add the contribution of a plus b plus 1 multiplied by a plus b plus 1 plus 1, that is n multiplied by n plus 1 divided by 2. This would be the new string. So I would subtract this and I would add this and I would see what is the maximum intermediate value. So I would go here and keep 0 and 1 and see. I would go here and keep 0 and 1 and see. I would go here and keep 0 and 1 and see what can be my answer to this. This is why what we did was, we are taking out the previous values, that is a multiply, let's say the current value is a and this value is b. So this is a multiplied by a plus 1 divided by 2. So first we are removing the contribution of this substring a, then removing the contribution of substring 2. Then now the new length when they both would collaborate and a new character is inserted in between. Now the value would be A. Let's say this is A, this is B. A new character is inserted, only one. So A plus B plus 1. So A plus B plus 1 is the new length. And A plus B plus 1 is the corresponding to the formula n multiplied by n plus 1 divided by 2. So now at each step, we would find out the answer at each step and see, like at each point, we would go and try to keep 0 and 1. We would go and try to keep 0 and 1. We would go to this point, try to keep 0 and 1 and see, because we can keep only 1, 0 and 1. No? So we can do this. So now the code as a whole would look something like this. So quickly tell me if you are able to comprehend this or not. So I would simply open up the problem statement for the last one. Tell me the line number at which you're not able to understand. So I just need to go to washroom because it's very cold here. Just give me 1 second. Okay, so seems like no issues are being asked. As the number of audience is quite less, so I need to assume that you people have understood, and then we can move forward. By the way, let's move on to the very last problem of today. I didn't really like this problem because of these constraints, like these all 2, 3, and 4 and multiple like this makes my head go buzz. I didn't like this, to be honest. Okay, if you just ask me an honest review. Okay, because seems like, okay, so fair enough. Let's take out this. Like it is. I would show you a point where it seemed like it was done. Let me tell you a point. Okay. Like, see, I would tell you that if they were trying to make it hard, then why didn't they do it in consistency? I don't understand that. That is my whole point of concern here. So you don't really need this text. That is why I'm just concealing it in bit at the back of my head. So see, the problem statement tells us that we are given a L and a R, and you can choose any value from L to R. You can choose any value from L to R. Okay. The next thing that is asked is determine the maximum sum after performing the following operation. What is the operation that I need to do? Okay. I need to select any value from L to R. Let's say I selected K, and the K should be the value of K should be from L to less than R. Value of K should be equal to this. Okay, fair enough. Now, what needs to be done? For the first 1 to K, what I need to do is change all the odd indexes to their absolute value multiplied by -1. Seems confusing. But here we are told that, see, here they have mentioned it somewhere. Only we can select any possible length. So if we select any of the first K elements and its index, which is odd, so we have to make it negative. So it just means that for first 1 to K, if the index is odd, we need to make it negative. They could have simply mentioned this. Okay. The remaining K elements is 2 and its index is 2, which is even. So we need to make it negative. Okay. So even we need to make it negative. You can draw out from here if you don't want to read this. Okay, like the result turning out from that would be, if it is odd, we need to make it negative. They could have mentioned just this, but they told that change all the indices to their absolute value multiplied by -1. Simply tell us na, that make it negative. They could have simply told it. Change all the even indices to their absolute value. That means just make it positive. Keep it simple. Change all the odd indices to the absolute value. This means that here, if it in case of odd value, we need to make it positive, and here in case of even values, we need to make it negative. So this flip in the idea, okay, this flip in idea, I didn't like it, to be honest, like that much. Why? See, if it is an odd, we need to, if from 1 to K, this is talking about, okay, so see, so it is told that we have 1, so let us draw it. See, it is told that select a K, select a length, select a value K. Now there would be 1 to K and K to 2K. It would be something like this: K to 2K, that is K plus 1 to 2K. There would be two strings. Now the table would be something like this, that from 1 to 2K, in the odd indices, you need to make all the values as negative. In the even indices, you need to make all the values as positive. If you don't understand these all lines, I would suggest you that you read up this explanation. Then from this, for the second half, what you need to do is, for the odd indices, here you need to make it positive, and for the even indices, you need to make it negative. Okay, so there is a flip in the idea, which makes it a more inclined towards implementation problem. Okay, so now, which makes it more like an implementation problem. Okay, fair enough. This is the table that you need to do. Okay, instead of doing the rough work, we can directly jump on and get a solution. To be honest, implementing that is a headache, to be honest, but jumping to the solution is comparatively easy. Why? Because let's say the value of L given is 10 and R given is 15, and let's say given the array is, given the array is A1, A2, A3, A4, A5, A6, A7, A8, A9, and A10. So let's say the given L value is 1 and R value is 5. Let's take a smaller value. Let's take L is equals to 1, R is equals to 3. So we can take any value that lies in between L to R. So let's say we took 1. If we took 1, then we can select 2k, that is, we need to select the subarray of size 2 multiplied by 1, that is 2. So we would select this, process this, and get the value. We need to select this, like we need to select all subarrays of size 2. Then we need to select this and process this. Then we need to select this and process this. Then we need to select this and process this. Then we need to select this and process this. Then we need to select this and process this. So you just need to process all subarray of size 2. We need to process all subarrays of size 2. What do we need to process, to be honest? I would tell you that also. How do we process? We want all the sum of even indexes and the sum of odd indexes, and make it odd and even and get the sum. Like we are told that odd indices must be made positive, so we would have the absolute value of odd indices and negative value of like even indices, and that would be my answer. Same goes for the value 2. So 2 multiplied by 2 is equals to 4. So we would start selecting all subarrays of size 4. All subarrays of size 4. So here if you observe, we need to work on what are the different works we need to do. So this is what you need to do. And there is an observation here. The observation here is, even though the constraints are very big or seems like very mighty on this end, but there is a small thing here, that L to R is minimum of n by 2 or 50. So now I can say that the maximum value of k that I would take is from 1 to 50, because L minus R is equals to 50. And 50 is easily achievable. 50 would be a constant thing. No? It is very small. So now, what are the different things we need to do? We want to work on fixed size all subarray. At each point, at each k, we need to do our operation on fixed size. Like we need to do processing on fixed size, or like let's say size 2 of all the possible subarrays. We need to do this. And the very next requirement is, we need the sum of odd indices, we need the sum of all the even indices. And the array value is not changing. So we need to do something with sum of a static array. This is how experienced programmers take down and break down the problem. Okay. So if at any point, this is the point where I would focus more in intuition rather than just solution, how you can achieve the solution, that is comparatively most important part. So if I want to process on fixed size subarrays, fixed like subarray all, like I want to process all possible subarrays of size 2, size 3, size 4, size 5. All possible subarrays of fixed size. Whenever I need to do this, then I need to think of sliding window. I would give you more idea about this. Like if the size of the window, if the size of the subarray is variable, then you should think of 2 pointers. Okay. But if the size of the subarray is fixed, then you should think of sliding window. Then we want to process the sum of a static array. We want to do something of sum over the static array. Okay. So we are operating on sum over a static array and the elements are not changing. So sum and array. We get the idea. Okay, this is an idea of prefix sum. So this is how the intuition would kick in of sliding window and prefix sum. So basically this problem is a combination of sliding window and prefix sum. If this problem was made simple of just 1/2 1 to k, if this problem was not broken down into these two conditions, then this problem would have been an absolute beauty. But kind of I think that this is an unnecessary headache and this doesn't teaches you anything. Like make it into two halves. What do you think about this? The only learning out of this was to use sliding window and prefix sum together in a problem. This was the solution, but the taking the headache of that, I think so, not required. Okay, fair enough. Let's move forward. So the first idea is sliding window. How would you process the sliding window? So see, we have A1, A2, A3, A4, A5, A6, and A7. So see, let's say we are processing all windows of size 3. So in the first window, the sum would be A1 plus A2 plus A3. In the second window, the sum would be A2 in the second window. This is the first window. This is the second window. The sum would be A2. The sum would be A2 plus A3 plus A4. So if you observe that at each window, one element is going out and one element is coming in. So you can just add the sum of A4 and subtract the sum of A1 and that would give you the contribution. This is how I would use sliding window. Application of sliding window is comparatively simple. Now the next idea is how would we get all the even indices and odd indices. So let's say we have the values as 1, 2, 3, 4, 3, 7, and 2. And the indices are 1, 2, 3, 4, 5, 6, 7. So now what I can do is I can simply, this is prefix sum of odd, this is prefix sum of even. So what I can do is I can simply use up this idea odd. Let us first call it odd. So first we would copy the value. Then we would go to the next odd. Previous odd plus current odd is equals to this. Previous odd plus current odd is equals to 7. Previous odd plus current odd is equals to 9. So we would just iterate on I plus 2, I plus 2, I plus 2. And we would get, so if I want the sum of all the odd indices till 5th index, I would simply say 7. If I want the sum of all the odd indices till 3, I would get 4. So we simply ignore all the even values. Now, simply for even also, we can ignore all the odd values here. So now what we can do is, we can simply do something like this. We can have the first even as copied, then 2 plus 4, 6, 2, 6 plus 7, 13. So now if you ask me, what are the sum of odd even indices till 3? I would say 2 only. What are the odd indices till The value 6, I would say 13. So this is how we can make two arrays of prefix sum odd and prefix sum even, and we can process the result. Now the solution is comparatively simple. So what we do is, if it is an even value, if it is if the current index is odd, we process the odd prefix. If the current value is even, okay, we process the even prefix. This is what we do. Odd and even, odd and even, odd and even. This is what works. Now the very next step that we do is, from L to R we start walking around. Okay, this is I. Okay, now if we get the value of the prefix sum odd and even, and this is, these two are just this long statement makes all the difference, to be honest. And this long statement is nothing but implementing the point 2 and 3. The implementing, either it would be point 2 or either it would be point 3. Either this is implementing point 2 and point 3. Below if statement is point 2 and 3. So what does this do? I would tell you that if the first value is odd, then it would take all the odd values. If the first value is even, it would take all the even values. And next, it would have the sum of all the values, and then we would compare if this new sum is greater than what we have found. If it is, we would save the location and what is the maximum sum, and then we process it. So this is just like processing all the key subarrays with odd and even. So if this was not divided into 2 k and k plus 1 to n, then this statement was just 1 and the problem could have been simple. This is implementing the if statement 2 and 3. Rest everything remains the same. Only learning out of this is the usage of prefix sum and sliding window, which is comparatively on a general side. Okay, so I would still give up this solution. So no one is here at this point, so there is no point in waiting. So still, if you have any concern or queries or want to ask anything, like due to absolutely very low number of live viewers, I think that I need to end here, because I think I rarely would get any cross questions. Still, if you are there, if you're watching, or if the YouTube algorithm is not working right, let me know and then I can process it. So apart from this thing, if you want any more explanation or any more points that you are not able to understand, please let me know about that and I would try to explain it in a better fashion. So just consider asking me on LinkedIn. This is my LinkedIn URL. So that's it for today. If you are a person who is watching this stream and the recorded version, feel free to like and comment on this video so that the reach of this video could be increased and this work could be justified. But this time I want your suggestions. What do you want? Like, what do you want the weekly coding of the next one should be done? What are the good and what are the bad about it? What should be changed? I want your views over this. So that's it for today. Thank you and have a nice day.